Good morning, guys. I don't know if you could hear me. Good afternoon, guys. Can you hear me? Those of you on Teams, can you hear me? Thank you for the confirmation. I'm gonna share now my screen. Please again update me. That one. Do you see the screen I'm sharing also? Again, just a time, please. Thank you, Timina and Tembo. Thank you, guys. Therefore, as I sent this morning, I will be discussing on PHYV101 test number 2 that the PHYV101 student has wrote yesterday. The questions are very interesting, and whilst invigilating the test, I've also looked through how students are struggling basically to solve the problems. That's why I decided this morning, instead of morning or afternoon, instead of going into the normal tutorial questions that we have on the Moodle, I decided to go through this problem. Therefore, guys, if you agree with me, let's go step by step, and let me check if those people on the YouTube, yeah, thank you, YouTubers, please. There are currently 3 viewers on that side also. Guys, chat with me. I don't think you could interact at this stage because there is nothing connected to the YouTube. You guys will be just watching. If you have a question, I will be popping in and out on the YouTube side. Please drop me a message, like for example saying I'm saying hi on the chat window. Then I know I will attend your questions. I will be popping in and out. Those of you on Teams, don't hesitate. If you want to have a question, just stop me anytime. You could unmute yourself. Just ask me a question. Please don't hesitate. Don't worry about interfering. I will be happy if you interfere me, saying that I don't understand. Why do you that? What is the objective? Or if whatever question you wanted to mention in between, please don't hesitate. Happy? With that notice, my tablet is sleeping. You might have seen it, yeah. And I'm going back to the tablet now. Therefore, let's start. This is as could you see. I'm gonna pull a little bit up and then maximize that. This is the first question. Is basically about applications of Newton's second law. Remember, on the Newton's second law, what we have is we basically have the force. Let me reduce my pen size. Come on, I want that one. And yeah, why she is thick then? We will be looking as the sum of all forces acting on a system must be equal to mass times acceleration. This is what we are looking for. This application Newton's second law. If you see the question, sometimes the question itself is vague. I've seen a student struggling. For example, what? In this case, there are 3 objectives connected. This is what the student couldn't pick it up. Connected on a table. They are connected. What does it mean? M1, M2, and M3 is a connected system. And the student's question was, he said, determine, this is where he was struggling with. He said, determine the acceleration of each of the objects. That was the question. And the student was confused that, why you ask me the acceleration of each object? But Professor Tim, when he put this question or this statement in, is basically asking the student, do you understand that for a connected system, all objects will move with the same acceleration? Therefore, the answer to the student from me, even though I didn't answer during the exam or the test time, would have been, oh, it is a connected systems. All connected systems have the same acceleration. Therefore, that connected is an informative indicating that in a connected system, the objects move with a similar acceleration or the same acceleration. Therefore, we know now mass 1, mass 2, mass 3 has the same acceleration. Let's agree there. But let's go back to the question and read by one by one. The first question is, before I go in, remember the coefficient of kinetic friction is only between M2 and the table. Of course, you could see there is a friction there between M2 and the table. M1 and M3 hanging. Therefore, they don't do that much damage. You know what I mean? Damage is they don't have any frictional force involvement. The only worry for the friction, therefore, is M2. Again, look into the equation. M1 is 4 kilogram. M2 is 1 kilogram and M3 is 2 kilogram. By then, you have to decide which way is the acceleration. Is it going to be to the left? Like, is it going to be, let me get my pen. Is it going to be this way? Or is it going to be like this way? For me, it was straightforward. And the one that was what the student also, some of them has got negative acceleration. By the way, even if you decide the system moves to the left or to the right, it doesn't matter. If you get a negative acceleration, the implication is your assumption was wrong, but the magnitude is going to be exactly the same. Therefore, if you come up, you also, those of you in PHYV student, if you did this expression or this example, this question rather, and then got it a negative acceleration, means your suggestion or your hypothesis which way the object accelerates is wrong. Otherwise, the magnitude should be the same. Therefore, M1 for me, because M1 is heavier, of course, you see, M1 is 4 kilogram, this system moves that way, down this way. That's the first assumption. Therefore, everything moves that way. What does it imply? M1 will move this way, down. I'll show that's the direction of M1. M2 will accelerate that way, and then not M2, M3, M2 also move this way. Therefore, the direction acceleration is counterclockwise. M3 move up, M2 move to the left, and then M1 drops down. I have made my assumptions clear. 2, because the pulleys are frictionless, you have to also worry about it. And then massless is supposed to be added. The pulleys doesn't have mass, that is have friction. What is the implication? The implication is, I'm going to remove the direction of acceleration now. The implication is the tension in each cable between, for example, this section and that section, the tension is the same. Because the pulley does nothing. There is no energy lost on the pulley. The pulley is not turning. It's massless and frictionless, therefore good, happy. That the section of the tension here, the section of the tension there is the same. But because M2 is in between, this tension is different from that tension, for example. They are not the same because M2 affects the in between. Again, between M2, this section and that section, the tension again the same because the pulley is massless and frictionless. We're happy with that one. With this knowledge, therefore, let's go to the question. The question is, the first one says, draw a force diagram. Free body diagram, basically, acting on each object. I hope you guys listening to me. Therefore, I say the mass one will be moving down. Therefore, there is a force. This force, I'm going to pull a little bit up. I'm going to call it M1 times gravity. It's down. Gravity always pulls down. Then I will say, okay, if that is the case on M1, there is a tension, then let's call it T1, that pulls this thing up. Because the pulley is massless, we are finished with M1, basically. With M2, the tension is pulling this way, let's call it T1 the same, because this pulley is massless, and what I mean, this is, I'm talking about that pulley, I don't like to write so many things. Therefore, T1 is equal to T1 on both sides. Then, as of course, M3 also want to pull this thing down. I'm going to put it down, and then I will say M3G is down. I'm keeping for number 2. Let's finish there. Let's say, call this one tension T number 2. Again, you remember the tension is the same across the pulley. I'll call this one, it's pulling up. Then this is going to be that way. No, a lie. That's wrong. The tension will be from mass, it's going to pull that way. It's right, isn't it? This tension pulls which way? It's going to go that way. Come on, man, right. Come on, yeah. Let me remove. Yep. Therefore, up, down, therefore this is that way. It's going to pull mass M2. But the same tension, T2. Agreed. Then let's go to mass number 2. For M2, always the gravity is down. We know this one, M2G. Then there is a normal force because of the table. Let's call it N. And there is additional force because of the friction. But we know that we now agreed the system is moving this way. That is the direction of acceleration A. Always frictional force acts in opposite direction to the motion. What does it mean? If M2 is moving to the left, therefore there is a frictional force F. That is what question number 1 requires you. Draw a free body diagram indicating the net force on each of the masses. How many we have for M1, T1 and M1G? For M2, M2G, the two tensions across the normal force plus the frictional force. Provide that you know the direction of acceleration, or you assumed, and then you have to indicate that the direction of the force is opposite to the direction of the motion. On M3, it is easy. Gravity always down, the tension pulls up. You happy up to now? You should be. I'm just listening in case, I draw up there. Okay, number 1, A, I've finished. That would have been on this down diagram, but it doesn't matter. We finished there. Then, B, are you guys happy with the drawing? Let me check if my cubers has a question in between. I don't see any question from the YouTubers. What about the teams, my team? Are you guys happy? Thumb up about the drawing. Okay, Petros, thank you for the clapping. Okay, good, then at least there is follow-up. Let's go then. Let's make use of Newton's second law and write 4 equations. He gave you, I'm just gonna write here. It's easy to put it here. What are the 4 equations you could think of it? Go to actually the mass, the free body diagram. I would say for mass 1, let me use it number 1. For mass 1, I'm talking about mass 1. Then we said it's moving down. Then I will say M1G minus tension T1 must be equal to M1A. I will use the same acceleration for everybody. I know they move with the same acceleration. That is question number 1 for mass number 1. For mass number 2, I'm talking about M2 now. This thing moves to the left, accelerate to the left. Therefore, I will say T1, now what is that? Yeah, T1 minus T2 minus the frictional force must be equal to mass times acceleration, M2G, now, and M2 common acceleration A. I've got 2 equations already. But I should be careful here. What else do I have about mass number 2? I've got also the vertical component. By the way, if I have to indicate this component is y, that component will be x. Therefore, mass number 2 actually has got 2 forces acting on it. The tension, horizontal side, x component. The y component is the normal force, and then mg. I could see there that the additional one is the normal component from that. The acceleration on the y-axis is 0. I will say the normal force n is equal to mg, m2g. I've got 3 in principle. 1, 2, 3. The fourth one is the fourth equation that the Professor Tim is looking for is for m3. Because again, m3 it moves up. Then I will say T3. No, where is T3? T2. Sorry about it. T2 minus M3G must be equal to M3A. You see, I set up my equations about the M1 for M2 for M3. And remember, in this equation especially, I don't know what my force is. Then, if you are good there, I know that the frictional force always is mu times normal force. But I know my normal force is M2G. I could put this one, mu, the kinetic friction, M2G. I have got a good equation. You happy up to now? If you're not, please don't let me go. Otherwise, we'll be struggling with the understanding. Question number B, we are done. Therefore, you have got your marks. You have got 4 equations. You have set it up yourself for C. That I will be using for C to determine the acceleration magnitude as well as the direction. You see, he asks you what is the direction. The direction is basically to the left. Every system moves. M1 moves down, M2 to the left, and M3 up. That's what they're looking for. Any question up to now? I'm listening, and you guys on the team, I don't see. I gave you the chance. You could stop me anytime. My YouTubers, they are not commenting, but they are there. Good. Then I'm gonna go. How do I go for acceleration then? To find the acceleration, maybe you are ahead of me now. You have to use equation number 1, equation number 2. Don't worry about equation number 3. Yes, of course, you're going to use equation number 3 and then equation number 4 all together simultaneously. Look how I'm going to go. Let's go. I'm going to come a little bit here. I'm going to write all the equations that I put now. What we said about M1 is it's moving down. M1G minus T1 is equals to M1A, we said. For M2, if you remember, T1 minus T2 minus that frictional force. In that frictional force now, I'm going to write mu, the static friction, M2G, that was the frictional force, must be equals to, I'll go back to my red pen, and then M2A. And then from the third, M3, I'll have T2 is up, yes, minus M3G must be equals to M3A. You see, I've got now all the equations ready. Then you see, if because we assigned the direction of the velocity, no, the directions of the tensions properly, check your equation. T1 cancels here, T2 cancels here. I'm adding down everything. Therefore, you could easily see that the M1G minus mu M2G minus M3G is equals to M1 plus M2 plus M3 with the common acceleration A. Have you seen? Therefore, your job is easy. You just add equation number 1, equation number 2, equation number 3 all together. Then you simply set up your equation. Then now I know everything except A. Therefore, the acceleration equation must be, if you see G is everywhere, I'm going to say G into M1 minus mu M2 minus M3 over the sum of M1 plus M2 plus M3. I did. I've got everything. Then if the next step is, because I was sitting in the class when a student writing, I also scratched with the pencil on my handout. I said, okay, I know the values now. It's 9.8 into M1 is 4 minus M3 is 2 minus M1 is 1 kilogram, and the value of that one is 0.35. 0.35 times 1 is this itself divided by 4 plus 2 plus 1 is 7. This is meter per second square. Thought I got a pencil. Up to here is going to be meter per second square. Then if you put this one into your calculator, I'm not going to drag you, I got about 2.31 meter per second square. If you get this acceleration, you should be happy that this is the overall A. You see, it ended up, my acceleration is positive. I am happy that the direction is as indicated on the diagram. It will be moving, M1 will move down, M2 to the left, M3 up. Holding, in case somebody want to say something. You guys okay? Timia? You guys happy? Up, down, or up? Yeah, thank you. Thank you. Let's go. Let's continue then. I can't wait to finish quickly. Let me just have a glance on my YouTubers also. YouTubers, you're not saying anything. Oh, I don't want, and you are not liking the presentation. I'm teasing. You will come soon. Then the last C, let me go back and remind you, those of you FVV especially if you are there. We finish the acceleration. Now determine the tensions in the two chords. Meaning, you see it, even he simplified, there are only two tensions. This is the same tension, we call it T1. This is the same tension, we call it T2. One of the students actually spoke with me after the test, and they said that, how I'm going to get this tension then? I don't know. The acceleration is an unknown. How can I get? And my answer to him was, of course, once you find your acceleration, why you don't go back to one of the equations? For example, that one. You see, I'm going to use this one to find tension number 1, and then I'm going to use this one to find tension number 2. What I mean is, let's go. Now, I think I have a space here. Yeah. I'm going to use now, using it from equation number 1 that I would have written, M1G minus T1 is equals to M1A. Then I know my acceleration, then T1 would have been, if you take to the right, it's going to be M1G minus M1A, or I could say M1 is common, M1 into G minus A. I know everything now. Then I think I'm running out of space. M1 is 4 kilogram into 9.8 minus 2.31. You guys finish that one, and then I calculate if my handwriting is visible to me, even 29.96. That's what I got, 29.96 with Newton. I'll call it like about 30 Newton. If you say that one, you should be happy. In the same way, I'm gonna now erase this one, guys. If you are busy, you don't need to copy. This one is recorded. Oh, I'm supposed to record on the Teams, huh? Sorry, let me start recording now on the Teams. In case somebody start recording, if somebody is interested, we could go back. The good thing is, it has been busy on YouTube, therefore you could get it there on the YouTube also. I've started recording on the Teams as well. Why I go there is actually to go back to, T2. Then for T2, I said, I'm going to use equation number 2. Therefore, you could easily say that, come on. I had this. You see, I lost everything that I did. The good thing is I don't care. You see, everything that I've been doing, don't worry. That's why I record it. Next, I'm going to come here. Then, for T2, we said if it's up T2 minus M3G, must be equals to M3A. I remember that equation that you put for equation number 3. Therefore, you could see that T2 must be equals to M3A plus M3G. Take that one to the right, which is M3 into A plus G. Then which is equals to M3 is 1. A plus G is basically 2.31 plus 9.8, and then I put this one. I got about, by the way, 24.22 Newton. I will assume as if you get 24 Newton, you guys, you should be happy. I'm holding if in case somebody jumped out and they said that, yay, I got it right, I got it wrong, or I didn't know how to do this. You're welcome if you want to interfere once again, or those of you on Teams. And if you keep it quiet, I'm taking as if it's positive. We're happy. No question? Just going back forth, and therefore, if those of you FVV students especially, expect such sort of equation obvious, but you should able to do it properly. Just draw your free body diagram, indicate the forces, assume the direction of acceleration, and then set up your equation, go for it. Solve it like a simultaneous equation by removing one from the other. And then if you come up with a negative acceleration, it's an assumption wrong, but your magnitude should be exactly what you're looking for. Okay, let's go. The next question is about this particular one. It's a circular motion, basically. Let me zoom it in. Here you go. It says, question number 2, if a 1,800 kilogram car passes over a bump in a road which has a radius of curvature of 42 meters, what force does the road exert on the car at the highest point of the bump if the car travels at 16 meters per second? Or if you remember, this is kind of reminding you about a circular motion around a circle. If just to remind you that if you have got a particle that undergoes a motion, think of a simple pendulum, or not a simple pendulum. Connect your like a ball by the end of a string, and then if you make it turn on your head, basically what you see is it undergoes circular motion, where the radius is r, that's the radius of your rope, and then it must have a mass, and then it must have a tangential acceleration. Let me use another pen. Not this one is not acceleration. See, tangential acceleration, a tangential, and then also have a radial acceleration. This is a radial. If you remember, this radial acceleration causes a force. The centripetal force, which is center seeking, exactly the same is also centrifugal force, which is pushing it away. If you cut the rope, for example, the ball will flow, but it moves in tangential to its path. Remember on test number 1, we ask you this one, which way is the ball will fly if you cut off the string, and then most of you got this thing right. Anyways, it's not there now. What we are interested here is if this object, in this case, can I go undo? Yeah. Now let's consider that object is not connected by a rope, rather it is going under like a circular motion. Then again, you have to indicate all the forces acting on this particular mass at an instant of time when it is at highest point. This is a vertical circle. Then of course you most of the time, oh fuck, this thing again up and down, man. This tablet is ugly. Touch something, it will just run out of it. Sorry about my wording. She annoying me. You see, everything that has gone. Go back. I'm saying we have got that object. Now it is at the top. I mustn't touch the back pattern. I don't know how not to touch it. Therefore, my handwriting is going to be ugly now because I will be writing at a distance. The mass will pull down, obvious. Remember, mg is always down. But if this thing is moving at certain speed, it also have centripetal acceleration. Or if because it's not connected, think of like this rather. You're driving a car. At the curvature, at the curve, if your speed is fast, you know what you move. You feel as if you will be thrown out of the car. It's always outward. That is a centrifugal force because there is no string tied to it to pull you in. Therefore, there is a force that actually pushes you out. This force is called centrifugal, opposite of centripetal, center seeking. Equal in magnitude, opposite in direction. Therefore, let's say this one is F centrifugal. I'm going to call it CF. Sorry guys, I've got a irritated chest basically, and then I have to come again and again. Sorry about it. Then let's go. This force actually, remember, for any particle undergoing a circular motion, it has got an acceleration or a force which is mass times acceleration, a centripetal basically, which I call it equals to mv square over r. You know about this one. V square over r is center seeking force, the same as to centrifugal force. Therefore, there are two forces acting on this car at that instant of time. Therefore, if you go back to our equation, there is mv square over r. Then there is mg down, pulling. Then the question says, what force does the road exert on the car at the highest point of the pump if the car travels at 60 meters per second. We almost have set it up our equation. Therefore, the force, the normal force, basically what the road applies, that normal force must be mg minus mv squared over r. You see, mg is the weight of the car. mv squared over r is the force that push you out. If you curve on a car, and then if you don't reduce your speed, obviously you have seen it. You're gonna rush and then what is that? Collide against the side of the car, because it's a centrifugal force that push you out. This is the difference. At the highest point, mg is down, mv squared is r. You see, it's different. If the equation is on the side, it would have been different. What about at the bottom? It would have been different. What about on the side? It would have been different. Of course, the two sides are the same. Okay? Therefore, at this instant in the equation is simply mg minus mv squared over r. You know m is common, then the gravity g minus v squared over r. You have everything. V is 16 meters per second, it is given. R is 42, it is given. And then, of course, you know the mass is 1800, 1800, it is given. Everything is there. If you put this one in, accordingly, what I get is about 6,669, let me call it 69 Newton. This is the force that the road applies or exerts on the car driver system. Or if you guys, those of PHYV or PHYV, if you say 6.67 kilonewton, you are correct. Therefore, you expect a full mark. Upward, obviously, it's going to be upward. It's a positive, therefore it's upward. I'm holding in case somebody say, what are you talking? What are you doing? Oh, my YouTubers, sorry, the network becomes poorer and poorer, it says. YouTube is not receiving enough video. Our network is becoming poor. My team, oh, Timba, sorry, you raised your hand. I say, guys, speak if you want. Timba, come in, please. I just go back and I checked. You raised your hand. Petros? Yes, sir. I hear what you're saying, Temba. Remember, yes, if we, of course it exists, first of all, to say. His question, guys, if you didn't hear it, my headphone is also not good today. His question is, does this centrifugal force exist? The answer to you is yes, it does. Just go drive around and then curve around. You will see it push you out. Therefore, it's out-seeking actually. It exists. Yes, it exists. Why it point out? Obviously, it's opposite of the centripetal force. It's if it is a pendulum, Temba, if it is connected by a string, the string is obviously pulling you in. Then you would say, by that time, let me zoom it a little bit. By that time, I'm gonna draw now. If this thing is a string attached to it, if there is a tension, the tension always pulls in. Now there is no tension. This car is just moving. What keeps it pulling in then? It's actually pushing it out. It's a rolling out force. It rolls you out. I don't know if I bring you in. Let me just click on, let me bring on a Google. You guys, I'm bringing this side so that you could see what is centrifugal. Centrifugal force. Yeah, centrifugal force. Of course you could see. You see? Centrifugal force is an apparent. That's why you said, does it exist? It appears as if it is there. That's why they call it apparent. Outward force on a mass when it is rotated. You see, that is where it is coming. If it is not rotating, of course, if you are stopping your car at the top of the hill, you don't have something pushing you away. What comes is when you rotate about, then you feel the force. It appears out of nowhere. That's what apparent means. Think of it, says even, think of a ball on the end of a string that is being thrilled around, of obvious what I said also, or exactly what I've been saying. The outward motion you feel when you turn a curve is exactly here. In an inertial frame, of course, don't worry about that inertial frame. You guys, you are not to that level. Don't have a rotating system. Don't worry about it. Therefore, it does exist. It appears, and then it's outward if it's not connected by string. Did I answer you? Temba? Good, thank you. Others who are listening to our conversation, are you guys happy, or can you assist us also? It is an apparent force, obviously. Yes, it appears out of nowhere when the motion is included. The cause is actually the speed. You see, it is v squared over r. If v becomes 0, that apparent force becomes 0. It doesn't exist. It came as a consequence of the speed. That's why they advise you to drive slowly on the curve so that you don't come out of the road. I hope you guys pick up. Pick up means you will see what we are discussing. Temba, switch on and then speak if you want any. No, if the network would have been 0 if mg is equal to mv squared by r, but they are not going to be 0 now. V squared over r is less than g. Yeah, just go on. At what point it is 0? It's a good equation actually. At what point is the force is 0? Then g must be v squared over r. What should be the speed? Not to have a 0. By the way, you could calculate. It's a good view. If that you want to appear, when is it going to be 0? That means the g must be v squared over r. This implies that the v must be the square root of g times r. At this point, by the way, the force becomes 0. You don't feel the apparent force. That is it's a very good, even for those of you engineers. You could put a speed limit on a curvature. Say that if your speed is equals to g times r, g is acceleration due to gravity, obvious. R is the radius of the curvature. For example, on the roundabout, on the road, on the roundabout, if you know the radius of the circle, you could put a limit saying if you drive beyond that speed, you start to feel. If you drive below that speed, the force is 0. Or at that particular speed, basically, you say v is equals to root gr. This is beyond the equation, but yes, you could think of like that. Let's go. Here is also what I found out. A guy spent almost 20 minutes of his time thinking about this particular question. Please read through. Those of you PHYV students, PHY, which ones are which? The science student, which you will be writing that sort of test. Or the PHYV student also. You will be writing such sort of questions on your end of module assessment. I want you to pick it up properly. Look this equation. This question says, it's a 10 kilogram block which is released from point A. Of course, you could see where that point A is. It's released from there, and then it moves down as shown. The track is frictionless, except for section BC. You see the friction starts here. This is a rough road. Otherwise, the other place is smooth. Then, this object moves all the way here. Once it moves here, actually it compresses the spring, and then it says it kind of stopped there. And it has to squash, obvious, the spring. Then the question asks, the block travels down the track and hits the spring with a spring constant of 2,250 Newton per meter, and compresses it a distance of 0.3 meter from equilibrium position, meaning that is too far. What I've drawn is, what it says is, it was there, now the spring becomes like here. The mass must have stopped there. The displacement, the delta x that this thing move, this is about 0.3 meter. Okay, that's what you are given. And then it says, determine the coefficient of kinetic friction between the block and the portion of that road which is BC, which is 6 meter. This is equation. And then of course by now in my head when I see the equation, actually I felt of, oh, is it not to do with the conservation of energy? You might say, what do you mean conservation of energy? I know when the block is at that position A, it must have mgh, where that h is the 3 meter, h is equals to 3 meter there. Then when it is slowing down here, it will lose the potential energy, but it gain a kinetic energy. Then as it is here, there is no friction, nothing, but it is moving. I'm drawing as if it is moving. Then when it come here, it will lose some sort of energy because of the friction. But you know that the work then due to friction is given by F, the frictional force F, times the distance L. The L is given, which is 6 meters. F is, you have to find what the frictional force. And then when it passes this friction area, again it becomes frictionless, but it's now about to collide with the spring. Then it compresses the spring. When it does so, it will create an energy, elastic potential energy, remember? Therefore, its actually case is half kx squared. K is given, x is given, you have everything. Then I know from conservation of energy, the change in potential energy, you know this one, the change in potential energy plus the change in kinetic energy plus the change in, or work done due to friction, in this case, work done due to friction, or whatever comes. There are two potential energies, by the way, here. Gravitational potential energy and the elastic potential energy must be equal to 0, or conservation of energy. You don't need to go this whole equation in principle. What you should know now is, I will say, mgh, the energy with which it started, must be equals to the work done due to the friction plus the half kx squared. And I don't include even the speed. You see, it momentarily come to rest. You see, it starts with rest, v is equal to 0, nothing happened to it, it just dropped, and then now it came and momentarily to rest. Kinetic energy is finished. I don't need to have it even. Therefore, my job is basically to look in what is that frictional force, or what can I do to friction actually. I said it's F times the length L, but I know from my second law, or Newton's second law, when the object is actually here, it has got mg down, and then it has got a normal force up. Therefore, that F is actually mu times normal force times the distance L plus half kx squared. I'm just writing all together. Then I'm going to put that one equals to that normal force, because this object is not going up and down, is equals to mg. Then I could write mu, the coefficient of friction I'm looking for, mg L plus half kx squared equals to mgh. Then I'm looking for mu, that's the mu is in equation. I will say mu mg L must be equals to, I take that one to the right, mgh minus half kx squared. Then now I'm almost there to free my mu. Then I will say mu, the friction I'm looking for, mgl is going to be h over L minus kx squared over twice of, I'm thinking of mgl. I almost put everything in place. H is 3, L is 6, minus K is, what is that K? I'm going to read from the paper. K is, second page, 2250. 2250 times 0.3 square over 2 times the mass is 10 kilogram, 10 times the gravity is 9.8, L is the length is 6 meter again, all multiplication. If you put these things together, I got a value of 0.328. It's a unitless. If you get around 0.33, you should be happy. Then what did I do? Basically, I looked into my equation and then questions. I'm holding in case somebody say, hey, what are you doing? I don't understand. Guys, happy? Temba, it's only you who talking today. Oh, Sita, thank you for the clamp. That means you guys are happy with. I'm getting old. Okay, let's go. Where is the other? How many questions? I have 4, I think. Let's see. What is this one? Ah, the other one. I'm telling you, almost majority of, if not almost everything I work through, meaning I check the student when they submit. I just basically go in and then check how did they attain this question, how did they try it. I could see almost everybody is failing this particular question. I'm online. She's not working though. I checked this one. I don't know what the problem is. I could not figure out. It's not there. I changed it that one, but it's somewhere here.
It's probably
Somewhere there.
sorry.
No worries. Sorry guys. Then let me go back to it. I will tell you that the majority of our students didn't answer this particular question. Those who tried even, they didn't get it right. Please check for me. Just read it. It is within the reading though. Just get motivated. Understand even the question. It's about momentum. It says after 0.3 kilogram rubber ball, don't worry about it. It's a rubber ball which is dropped from a height of 1.75 meter. Let's put in what it talks. Let me say, okay, this is my floor. This thing is gonna be dropped off from there. This is my ball. It come off this edge. Now given is 1.75 meter. Then once it hits the floor, let me use another pen now. A bit down, yeah. Bounces off it is concrete floor and rebounds to about here. Let me, even though it is just going the same way, let's say it climbed up only this much, which is h is equals to 1.5 meter. That's what is given. The mass is given, the initial height is given. It's gonna go bow and then in contact with the floor, obvious, for a very brief time, and then it bounces off, and then it reach 1.5 meter below where it started from. Now the question is, determine the magnitude and the direction of the impulse. The impulse delivered to the ball by the floor. They know, or I'm talking about the student, the impulse I is always equals to change in momentum P. Remember, it's a vector. Obvious, the floor is going to push it up. The direction is basically obvious, it's going to be upward. But what is that? What is the magnitude where most of them failed to pick it up? For me, therefore, this is basically, come back. This equals to P final minus P initial. They must know this. But the P, I'm going to forget about that, the vector now. P is mass times velocity. It's a momentum. It's a mass times velocity final minus mass times velocity initial. Initial when it is coming down, final when it is before and after collision, basically. There is a collision going on. The question is basically, how do you find the velocities? But you have to use now your thinking. It's not only momentum, it has undergoing also conservation of potential energy, or energy, conservation of energy, basically. How? At this point, it has got, when it is, before it is released, it has got mgh. The moment it come and collide with the floor, it will have, let's call it this one, V initial. Then that V initial is the velocity with which this ball is coming to collide with the floor. How do I get, therefore, that one energy is conserved? mgh at highest point when it is started must be equals to half mv initial square. That v initial square is the velocity with which the ball come and collide. Why didn't the student pick it up here? Then you could easily see that the velocity of this, the v initial, must be equal to the square root of 2gh. Of course, you could see what I mean. You remove m on both sides, multiply to the other side, v initial is root 2gh, where that h is equals to 1.75 meter. We have solved it for that particular one. Which way is the question again? The velocity is down, it's moving down. I'm going to call it minus j. It's down. You happy up to here? Sevilla, you are sitting in front of me. Your name is appearing in front of me. Thank you. Nicola, Obe, Gosana, you want to say something? Your name is behind. I can't see if you are raising your hand or you saying yes. Good. Okay, good. Thank you, Sitia. Temina, also thank you. That means you guys you following. Great. Let's go. Then, if now know the velocity of the ball before collision, it is downward. It's going down, and then it has got the magnitude of this 2gh. Let's go. After collision, after bouncing off, now this is going to start with another v final. You see that v final is the velocity with which the ball start moving up. There is a difference. You might think, is v initial equals to not v final because this thing is just bouncing? Not really. It depends on if the mass, if the ball raised all the way or risen all the way up, that velocity would have been the same. Then that means the floor didn't take any energy. Conservation of energy tells you that if the initial velocity with which it is colliding is the same as to the velocity with which is going out, then obvious v final is equal to v initial. But we were given that it's actually only up to that height. Therefore, they cannot be the same. Again, I'm going to use the same principle. When it is after collision, when it is bouncing up, I will say half mv final square. You see, this is the one that goes up now. Must be equals to mg h2. I'm calling it h2. This one is h2. This is how far it is risen up. Then I'm going to drop that one. Then again, I will say v final with which after collision is going to be again root 2g h2, where that h2 is 1.5 meter. But I must know this one, it's along j. Momentum is a vector, therefore I must be careful about it. Then the first one is down, the second one is up. We're almost there, guys. Then if I put, I'm gonna maybe zoom a little bit like this. The impulse, therefore, I'll go back on that one. Must be m into v, v final minus v initial. But if you put here now m into the vector, root 2g h1, I'm calling it h1, the highest, no, h2 rather, minus of, because v1 is down, minus of the square root of 2g h1. You see that minus minus, m into the square root of 2g h2 plus the square root of 2g h1. You might say, why you say plus now? The plus comes from the very speed is down, you see, minus j. This one is up j. When you take the minus of the minus, it becomes positive. It's actually the sum of the two. Of course, you could see why energy also, in terms of the motion, it must have come on, fall on the table, bounce it up back. Guys, put together, what I mean is, the mass is, let me go into 0.3 into the square root of 2 times 9.8 times 1.75 plus the square root of 2 times 9.8 times 1.5. If you put this one, I got a value of 3.384 Newton per second. The number is just a calculator. It will spit out for you. But Why is the student miss it this question? Why it is difficult then? The difficulty comes for me is from the interpretation, the understanding. I'm holding in case somebody say no. Okay, Temba, you came back again. Please come in. Oh, just hold on. Yeah, don't switch off your mic. Let's continue. Remember, what I mean energy is conserved is mgh at the highest point equal to the initial. Let me admit somebody first. Who is this? Okay, so I'm adding someone in. Your question, Timba, or for the other also, he's asking where is the conservation of energy coming in? Timba? During the dropping, I could notice energy is conserved, obvious, anytime. However, during this system, the floor is gonna heat up. Basically, if you put a thermometer next to it, you will pick it up that because of this falling off the ball on a floor, the kinetic energy of the floor will increase, meaning you lose heat energy in the form of heat. However, what I'm saying here is mgh at highest point equals to half mv squared at the bottom. That velocity is the velocity with which the ball will be colliding with the floor. Therefore, energy is conserved. Then again, I'm using another one. When the ball now, after undergoing the impulse, after pushing the floor a little bit down, is going to bounce off. When it bounces off, it lost its speed actually. You see, the speed with which it is coming is not the same as to the speed which is going out. That lost energy is in the form of heat transferred to the floor. And I cannot say now energy is conserved because it is lost in the form of heat. But if you know the amount of energy lost to the heat plus the amount of the kinetic energy it is moving with, energy is conserved still. Temba? What do you use, for example? How? Are you saying, can I use V final square is equal to V naught square, which we started, plus 2GH? I believe you must come with the same. You see, I used deliberately plus because it's moving down, and you must have the same. Initial velocity is dropped, it's 0. Then you must actually reach the same conclusion. The final velocity is what I call it V initial here. You must have the same. You're not going to be wrong. You're welcome, Timba. Other guys, you could all prove me, please. Go in and then go, okay. And Kosana also saying yes, that's good. And the thumb up, I could see. Go on and then just check. You shouldn't use only the conservation of energy. You could solve using equation of motion as Temba is talking about. But this, therefore, you're not supposed to lose this. How many? 2 mark for the top one. Okay, we're coming for the second one. But yes, we spend a lot of time talking about only 2 mark. But yes, you guys, you're correct in whatever you're talking there. Let's go. We now got the impulse. The second equation says estimate. You see, now it's the estimation comes in. It doesn't matter. I also spoke with the professor team and saying that what if the student thought of 0.5 second, 0.2 second, 0.6 second. It doesn't matter, but you cannot say an hour though. It's not going to be in contact with the floor. You drop a ball from 1.75 meter, it's instant, it bounces off. Therefore, for me, I've estimated about 0.1 second. Or you could say 0.5 second. You're not going to be penalized based on whatever your assumption is. It's just a number anyway. Let's estimate 0.1 second. And then it says, estimate the ball in contact with the floor and use the estimation to calculate the average force. And basically what you would have done is, I'm going to clear my stuff for second part. If you have said, PHYV student, if you have said, then using that, remember the impulse I also defined as f delta t, the rate, the time. That delta t is, I'm taking delta t of about 0.1 second. Then I will see that f must be impulse divided by delta t, which I got based on my assumption. If it is 3.384 divided by 0.1, based on my assumption, I get about, of course this is a definition, 33.84 Newton. Or if you use 0.5, you get more, double of this one. But you will not be penalized depending on your assumptions. That the question is basically divide the impulse by the time you have assumed. Okay, how far? Oh, it's finished. Yeah, obvious. That is the last question. This is all then. Guys, I believe this is all what I've prepared for. What do you say? Okay. Sorry, my YouTubers, now they are all there. Guys, I'm sorry I left you behind. I didn't communicate with you. Ups and downs. Hopefully, you guys, you have been following. Sorry. So if we left the answers as 6669 Newton, will you get full mark? Yes. Sorry, I'm replying to a chat on the YouTube. Yes, this is question number 2. If you leave 6669 Newton, you are perfect. You will get a full mark, no problem. My teams, you happy with what we have gone through? If that is the case, we're almost gonna say goodbye to each other. By the way, what did Dr. Lindsay say she looks alike? Does she have any questions on this part? FVV students, do you have any question on your here? I don't know where you guys are. I'm not gonna bother. You guys, let's conclude. You will be writing a test when, I don't know what Dr. Lindsay said, but you guys, you are welcome to send me question anyway, anytime. As some of you have sent me even over the weekend, I don't have problem. I will answer to you if I can. With this, if you don't have a question, I'm saying thank you for joining me in numbers this morning or this afternoon, from morning to afternoon. And if not, I'll see you next week. Do we have next week? I'll see you next week on Wednesday, exactly the same time. Otherwise, thank you. And I will be holding on for the next 1-2 minutes if somebody wanted to ask a question. Some of you are shy to speak out. If not, have a good day. I'm just holding if there is any communication from that side also. Temba, come in. I'm gonna remove today. Okay, just speak. Temba.
So can you please clarify the dot and cross products of vectors?
Dot and the cross product. Happily I will assist you. You see in this, I'm gonna open my, I just wanted something. Don't I have a space? Oh man, come on. Something like this. What do you mean? Look, vector dot product. Where to go? Where to start? What I know of is, think of you have got a vector A in this way. Don't I have a pen? Vector A, now it's writing. If I've got vector A like along A1x, which is I plus A2j plus A3k, and then another vector B as B1i plus B2j plus B3K. If some of you looking for example, what's the dot product between vector A dot vector B? And you know, in terms of mathematics, this one is the magnitude of A, magnitude of B, cosine theta, where theta is the angle between vector A and B. That is basically a definition. However, if you have such a three-dimensional vector, what I advise you is the following. When you do this, A dot B means you basically take A1I plus A2J plus A3K dotted with whatever you have for B, B1I plus B2J plus B3K. And then remember the following. When you do a dot product, you only do it axis by axis. What I mean? The answer for this one is actually A1 B1 plus A2 B2 plus A3 B3. You might ask, based on our knowledge of dot product, why don't I do A1 dot B1, A1 dot B2, A1 dot B3? In principle, you have to do that. The same true for A2, the same true for A3, but the following saves you. What I mean is, sorry, when you do such dot, you also must remember that you making I dot I. Therefore, vector I dot vector I is 1, vector I dot vector J is 0, vector I dot vector K is also 0. Why? I dot I is the angle between them is 0, cosine 0 is 0. That is what saved you. I dot J is x dot with y, the angle is 90 degree. That is what saved you. This also is the case. Therefore, dot product should be, you simply multiply the component of the x-axis with the component of the x-axis of the other vector, the component of the y-axis with the component of the y-axis of the other vector, z with z. Done. You are happy with this one. This is what I suggest to you, you do through dot product. Cross is a problem. Are you happy up to dot product, Temba?
Yes.
Let's,
One
yeah.
thing, I just want to clarify.
Yeah?
How can I interpret that multiplying I head direction and I head direction give? What does it mean?
Oh, it means that, remember those eyes are a unit vector in the direction of x. A unit vector. The magnitude is 1. Therefore, I dot I means, in principle, if I write fully, the magnitude of the vector I times the magnitude of the vector I times cos, dot is not dot, is times. Let me use like times, normal times. Cosine of I and I is in the same direction, cosine of 0. You see, the interpretation therefore is, I'm going to remove this one, is this is the unit vector. Unit vector means a vector with magnitude 1. Therefore, this is basically saying 1 times cosine of 0 degree. Cosine of 0 degree is 1. 1 times 1 is 1. That is what is coming out as if it is 1. Remember?
Yes, sir.
Yeah, therefore the interpretation, the coming out of 1 is basically, because they are unit vector, you have got two vectors basically along x-axis, the unit is 1, and their magnitude is 1. Therefore, the dot product between them is 1 times cosine of 1, cosine of 0.
Yes, sir.
Good.
I understand.
Thank you. Let's go to the vector now, the cross. The cross, I don't know how you guys are happy. I'm also part of teaching in the second year mechatronics student. They are still struggling about this vector cross product. I will expect you to see the same next year though, those mechatronics students. You see now, this is what I do. Sorry. Vector A cross vector B with the same sort of A1, A2, A3 and B1, B2, B3. I will do this one is a vector cross product. How do I start? With I j, and then k component. First, remember, a cross b is magnitude of vector a, magnitude of vector b, the sine angle sine theta between them. This is basically definition. But when you do so, a cross b is different from b cross a. In terms of property, I forgot to say to you, a dot b is equal to b dot a. Doesn't matter. It's a scalar at the end of the day. 1 times 2 is the same as to 2 times 1. Either you reverse the direction, it doesn't matter. In terms of the cross, it's not true. Therefore, what do? Go to the vector A first. List them in this matrix system. Then I call it A1, A2, and then A3. And then I will go to the B, the second vector that I will be crossing. B1, B2, and then B3. Then I set up my equations. The cross product, remember the cross product between two vectors are a vector. It's not a scalar, it's a vector. Then the following is what comes out of this vector operation. Also in your mind, what I will be doing, remember the following. You see, keep this one in. I'm trying to draw the three-dimensional ijk vector. See, if this one is vector I, vector j, and then vector k. Think of x, y, and then z is outward. Always the following is true. What I mean is, if you cross I cross with j, you will get always k. It counterclockwise are moving. If you cross j with k, you always get I. Check the direction of the arrow. If you cross k with I, you get j. You see, remember the right hand rule also. I cross j give you k, j cross k give you I, k cross I will give you j. The opposite is negative. What I mean is, if you going j cross I, from j to I, you get negative k. Keep this in mind. Therefore, when I'm looking for the I component, this is a procedure, therefore, erase this one. I'm looking for I component. Erase that. Then what did I say? I will be crossing j and the k. But I know that to get I must cross j to k. That axis is what I'm going to cross. Therefore, I will start here. This first, what it means? A to B3, A to B3. Now I'm going opposite from K to J. Minus A3, B2. This is along the I component. I finish the X component. I start with J, go to K, is a positive. Then I go from K to J backward, is a negative. That's where this negative coming, that negative I'm talking. I finish with the X component. Plus, I will go. You see, sometimes on a book they use minus. I will tell you what. Just forget about it. I'm going to use plus. I'm going to follow my positive rotation here. My following is this one, therefore. I'm going to say under so that it doesn't write so many things there. I'm going to use plus. Just follow up what I'm saying. Then, in this case, I'm going to erase. Just hold for me. I want to use another pen. This one this time. I'm going to now erase this one. I didn't change my pen. Then, what I left with? I left with K and I. Always, I have to go from K to I to get a positive. Therefore, I'm going to start from there to here. That's why I start with positive here. Then I'll open my stuff. A3, B1, A3, B1, minus, because I'm going from that way now. A1, B3, this is along the J component. You see, sometimes when the book uses, they don't care. They start from I to K instead of K to I. That's why this one is either plus or minus. I always fix myself into one. I don't want to bother myself. I just use a positive everywhere, but I follow this counterclockwise direction as a positive. Then done with 2. Then I left with the third one. Plus, again, I'm using plus. Then I'm looking for the K component. Then I know when do I get a K? I must start with I and then go to J. What it means is I'm going to go A1, B2, which is A1 B2 minus A2 B1 in the K component. Therefore, still struggling, you see, with this carbon. Sorry about it. Therefore, I now have the cross product between two vector in X, Y, Z component is given by this equation. Yours at this stage in the second year, you guys, you don't struggle with 3-dimensional. You mostly with 2-dimension. Even if it is 2-dimension, you just remove the K component, but work through. That's what I said to you about the vector cross product and the dot product. Nestle is admitted. I don't know why somebody is joining us now. Nestle, sorry, we almost have finished our discussion. Temba?
Yes, heard you.
Yeah, you happy about it? If you have any your suggestion, please don't hesitate.
Okay, but isn't there supposed to be a minus sign somewhere?
Yes, you see, that's what I was talking about. On the book, they use this. Can you see where I'm writing? You see there, they use negative. But
Yes.
they put negative, but they will be writing then, they will be doing A1 B3 minus A3 B1. You see, they interchange these components.
Oh, so that's the reason why they.
That's the reason they put it negative. If you know the reason is or what I mean, why I use positive is I always rotate in counterclockwise when I'm doing this vector algebra.
Okay.
Yep. And my YouTubers also, they are still following up. Sorry guys, and this YouTube I could see now. Thank you for the liking. They're just busy down there, but yeah. This YouTube is also, it depends on how fast our internet is. Sometimes it's slow, sometimes it's fast. Thank you, the YouTubers though. Temba, if you don't have question, we are almost about to say goodbye to each other. Nestle, the guest, TN. TN, I don't know if you joined us, the guest, I mean, yeah. You joined us late, but we have gone through the questions that I supposed to be coming with. Please, if you have, or if you are still interested with these questions, Nestle, I'm talking to you. We work through though about these questions about PHYV101. We work through. If you say, actually it is on the YouTube, you can go and watch the video, but I'll give you a chance. If you have a question, please let me know. Or which question do you really wanted to go into, if you don't need to miss it. Otherwise, you can go on to the YouTube and listen there. Otherwise, guys, thank you for those of you who are still hanging and listening to our conversation, not conservation. See you next week. Bye, Temba.
Thank you, sir.
Thank you. Sure. Bye. Bye. On my YouTubers.